on these models. This is the liver,
Gall, no. Pancreas.
stomach,
Stomach.
spleen. Sits like that. Flip it over.
Liver.
Now remember it's reversed. So this is the liver, this is the
Gallbladder.
gallbladder,
Spleen.
spleen. Any of these peach colored regions, those are small intestines. The gray ones are
Large intestine.
large intestines. Good. What's this thing running through here?
Pancreas?
Pancreas. This is the pancreas. This is the main pancreatic duct, actually. Remember, that's the stomach. Stomach is a hollow organ. This is glandular tissue. So we want to be able to identify the difference between. Can I do visceral and parietal on these? Yeah, remember the visceral layer is right in contact with the organ that we're discussing. Parietal's on the outer edge. There'll be a space in between. So I can put stickers on there and ask you parietal versus visceral peritoneum. I could do that with the stomach too. All right, couple more models. These models represent the digestive tract from the alimentary canal. This is the esophagus. Remember, it's stratified squamous epithelium. So we can see that here. Then there's a transition from stratified squamous epithelium to simple columnar. This is the gastroesophageal junction. Remember, we said you should be able to identify the difference between being in the esophagus versus being in the stomach. And that's what this model represents. You have stomach and then stomach to duodenum. From the duodenum, we go through more small intestine and then finally into the large intestine. So it's showing you the transitions between the different epithelial layers. It's also showing you the muscular layers. So in this case, these muscles are running out of the model at you. These are running horizontally. You turn it, and now they do the opposite. These are running horizontally, these are coming out of the screen. So this one's always neat to get a perspective as to, well, if you cut it this way, it's going to look like this. If you turn it 90 degrees and cut it, it's going to look like that. Okay.
Are those connected, like, are they in order? The way
Yes.
they're-
Yeah, they're in order.
So if you're saying they're connected, like I'm not seeing how they're connected when you say stomach, spleen, like you're going.
The esophagus leads into the stomach,
Okay.
the stomach leads into the small intestine intestine leads into the large intestine.
And it's just the different tissues as it.
You need great big villi in the small intestines for absorption. There's not much absorption that happens in the large intestines. We absorb some water, some vitamins, and then some electrolytes. So they don't need to have great big villi. In fact, you'll notice that there's lots of little white cells throughout. And those little white cells are the goblet cells. So you'll see an increase in the number of goblet cells as you get closer and closer to the large intestine. You'll also see these Peyer's patches start forming. And I'll show you all Peyer's patches in the histology.
Is that representative of the tissue thickness also? Or not so much?
Probably, because we need more musculature, right? Remember, there's lots of segmentation going on in the small intestine, little propulsion. And you need more propulsion in the large intestine. But I wouldn't say that that's necessarily the thickness of the individual organs. All right, lots to look at today. So please feel free to grab any of the models. We've got a whole bag of teeth over there. Some of them have little cavities in them. So feel free to look at them. Most of next week is going to be stickers and identification, and probably 3 or 4 histological slides for you to identify. But I'll do that, I don't know, if I give you 11, or sooner if you want. It doesn't take long. There's only like 6 slides.